Alright, this LeetCode question is called third maximum number. It says given a non-empty array of integers, return the third maximum number in this array. If it does not exist, return the maximum number. The time complexity must be O of n. So the two things to note are the time complexity, which must be O of n, and if there is no third maximum number, we just return the maximum. So the first example is pretty straightforward. The array is 3, 2, 1, and the result is 1 because it's the third largest number. The second example is the array 1, 2. Since there isn't even a third number, there definitely can't be a third maximum number, so we return the maximum, which is 2. And the final example is the array 2, 2, 3, 1. We know the max is 3, and we know the second max is 2, but what's the third max? You might think it's the other number 2, since it's greater than the last number, but we need our maximums to be unique. So in this case, our output is the number 1. Alright, one way to solve this problem is by creating 3 variables which keep track of the max, the second max, which is the second highest number, and the third max, which is the third highest number. The first thing we do is set the max equal to whatever the first number is. And then we set the second and third max equal to the smallest possible number, which is negative infinity. Now we loop over every element in the array. So we start with the second number because we already know that for now the first number is the max. So is 11 greater than the max? Yes, it is. So the first thing we have to do is bump the number that's in the max now to the position of the second max. And now we can make the max equal to our current element. And then we move on to the next element. Is negative 4 greater than the max? No, it's not. Is it greater than the second max? No, it's not. Is it greater than the third max? Yes, it is. So we'll make the third max equal to our current element. All right, next number. Number 0. Is it greater than the max? No. Greater than the second max? No. Is it greater than the third max? Yes. But we also have to check whether it's less than our second max. We do this because we want to make sure that the numbers in our max positions are unique. We don't want the same number occupying more than one max position. So yes, it is greater than our third max. So we'll just make the third max equal to our current element. All right, so now we're at the number 1. Is it greater than our second max? No. But here's the thing. Is it greater than our third max? Yes, it is. But this is why we also have to check to make sure it's less than our second max. It is not less than our second max because it equals our second max. So we don't do anything. We just move on to the next element. Okay, so finally, last element, is it greater than our max? No. Is it greater than our second max? Yes. So we make it the second max. So now that we've iterated over every element in the array, we know that our third max is 0. All right, let's get to the code. LeetCode has given us a function called third max, which takes in an array. So remember, the first thing we have to do is we have to create 3 different variables. We have to create max, which is equal to the first element in the array. That would be right here. Then we have to create 2 more variables. Second max, which equals negative infinity, and third max, which also equals negative infinity. So that would look like this. Second max. All right, now we loop over every element in the array, starting with the second element. So that'll be for let I equal 0, I is less than nums.length, I plus plus. And just to make it easier to follow, let's capture the number we're on in a variable. So let num equal nums I. Then we check, is the number we're on, which right now is the number 2, is it greater than the max? It isn't, so we need an else statement. Else, if our number is greater than the second max, but remember, we want the values at our maximums to be unique. So if that was our only condition, right now we would say, okay, well, it's greater than our second max, so let's make our second max 2. But we know that our maximum is already 2 because of the first element. So we need another condition. So is it greater than our second max, and is it less than our max, to make sure we don't have duplicate numbers. So let me just put this back, make this negative infinity. All right, so we need one more else if. This time we'll check if our number is greater than our third max, which it is, but again, we need to make sure the numbers are distinct. So we have to add an and. Is it less than our second max at the same time? I just noticed that I called this third instead of third max, so let me change this real quick. Okay, so the number we're on doesn't meet any of these criteria. All right, so we move on to our next number, which is the number 3. So we go to the first if statement. Is the number 3 greater than the max? It is. So now we need the number 3 to be our max. The way to go about this is we need to make space for our max in our variables. So we have to bump down whatever's in second max into third max, and we have to bump down whatever's in max into second max, and then we've freed up max to be the current number. So we'll say third max equals second max. In this case, they're the same, so we go to the next line. Second max equals max, which would look like this. Second max is now the number 2. And then finally, max can now be the number we're on. So max is now the number 3. Now we move on to the next number, which is the number 1. We do our check. Is the number we're on, which is the number 1, greater than our max? It's not, so we move on to the next else statement. Is the number we're on greater than the second max? It's not, so we move on to our next statement. Is the number we're on greater than the third max? It is, so we can just make third max equal to our number. That'll look like this. All right, so now we've iterated over every element in the array. Notice that we haven't filled in our second else if yet. It's basically the same principle as the first if statement. So if this were the second greatest number, what we'd have to do is bump down whatever's in the second max and make it the third max. And then, now that second max is freed up, we can make second max equal the number we're on. All right, so now we've broken out of our for loop. So now we need to return the third max. But we're not actually done. Think about a situation where there was no third max. So let's say our array was something like this. 0, 1. 1 would be the max. 0 would be the second max. So what did the question say to do in this case? It said to just return the max. So what we actually need to do is we need to check if third max is still negative infinity. If it is, we just return the max instead. If not, meaning it has an actual value now, then we'll return the third max. All right, so let's run the code. Oops. Forgot to make that second max instead of just second, so run it again. Looks good, let's submit it. All right, so as you can see, our code was faster than about 47% of JavaScript submissions. As usual, the code and written explanation are linked down below. If you liked the video, give it a like and subscribe to the channel. See you next time.